Hi, I'm DJ Ware. On this episode of the Cybergizmo, we're going to be doing a Docker build right after this. So I guess last time we talked a little bit about, at least in the Docker part 2, we talked a little bit about some of the basic commands, how to pull an image, how to run an image, how to stop an image, and so forth. And today we're going to be building a custom container of our own. And so we're going to start with building a custom image, and then we're going to deploy that into the container and run it. And to do that, but before we do that, actually, let's talk a little bit about the Docker architecture itself so you kind of get an understanding of the things that it can do. So there are three basic functions. There's the build, which allows me to create images of my own. There's the pull, which allows me to take images either from the public repository or a private repository that I have created. And then, of course, I can run those. I can actually take the images and start them up inside their own container. The management of the Docker engine itself, or the environment itself, is performed by the Docker client. That can either be a command line, or if you're running Docker Enterprise, then you have a GUI that you can use to manage not only the Docker machine you're running on, but also any Docker machine that's available to you in your environment. However, the Docker Community Edition does not have a GUI, but there are some third-party ones that you can get, and we'll talk about those at the end of this particular demo. So the next thing you have is the host environment that actually contains the Docker runtime. Now, if I refer to Docker to the host OS, I'm talking about the operating system that is used by the host machine that is running the Docker engine. If I talk about base OS, that's the operating system that's installed inside of a container, if you did install an operating system inside the container. You don't have to, as we have talked about before. And then, of course, you have the containers themselves, which are either the ones that have run or the ones that are running in your environment. And then, of course, you have the images, which is your local repository of images in which you can deploy your containers from. And then we talked a little bit about the registry. There are two types, actually three, but there's the Docker Hub, which is the public one. There's one that you can create called the private one. And then you could host one on the cloud yourself if you wanted to do that. But of course, that's beyond the scope of what we're going to talk about here today. To do a Docker build, you need a Docker file and a Docker directory to do the build in. So the first place we're going to go is the directory itself. So in my local directory, I'm going to create one called build, and then I'm going to cd to that directory, and then we'll create a Docker file. But before we do that, let's talk a little bit about what goes into a Docker file. So a Docker file is basically a set of commands you want the Docker engine to follow in order to create the image. And the Docker file creates one image. It doesn't. So if you want to be able to create stacks, that's what Docker calls them. That would be things like if I wanted to deploy a whole set of applications, each in their own container, I would use Docker Compose for that. That's the difference. So today we're going to be talking about just the single image deploy, and next time we'll talk about Docker Compose and how you can set up stacks. And I probably will touch briefly on some of the other aspects of stacks, but for right now we'll just keep things simple so that we can understand them. So back to the Docker file. Anywhere that there's a pound sign, that's a comment that you can use to describe the things that are going on in the file. A from command is basically the pull request, and that is saying this is the image I want to pull either from the hub or from a private repository in order to create my custom version of an image. And in our case, we're going to be pulling the Python-35-slim. Now, I'm following the same steps that's in docs.docker.com under the Getting Started for builds. So you can go there and you can kind of follow along with what we're going to do here today. But the only difference is I'm not going to deploy Python 2.7 because we are literally months away from its deprecation. It'll be gone. And so 3.5, it will be the current version of Python. So I don't want to really mess much with 2.7, and so I'm not going to put it in this build. Label command is used to modify metadata within the image. So that would be things like your description, version. It could also be the maintainer name. It might be some other tags that you might want to place in here to help people locate that particular image if you're putting it out into the Docker Hub, or if you're even putting it in your own local repository, would help others figure out what that particular container and image set does. Then you have work directory. That's basically a directory inside of the image that you're going to use to place files, or maybe you're going to perform some kind of make it a work area or something like that. But anyway, you're defining, I want this directory created. The copy command takes files that are in my host directory and puts them inside the image. The run command executes shell commands within the image itself at the time the image is constructed. So this might be used to pull down additional packages through either the apt or DNF or pacman or whatever command sets you use, Zyper for SUSE. But that would allow you to do that. It would allow you to run shell scripts that you needed if you had some other special setup you were doing on your system in order to host your application. So remember that the run command is only done at the time of the build. Expose is you're telling it that I have a network port that I want to make available to the outside. In the course of building the image, it won't actually make that port available. It just is a placeholder for that says to the Docker engine, my application is giving permission for this port to be exposed. And it's up to the person that creates the container whether or not to use that particular port or not. You have the environment, which is same as environment variables under Linux, where you have name value pairs that you're using as part of the application deployment process in order to if you have path names or something like that you're passing and you don't want to have to retype them each time, you can just use an environment variable to do that. Finally, there's command, and that specifies what it's it's like run, except it's a shell script that is a shell command that's going to run at the time that the container starts. So this would be things like I'm going to launch my application. I'm going to do some things that I need to do in order to set it up and make it working. So that's the difference. Run is done at the time of the build. Command is done at the time of the container run. One thing to say here that I didn't mention is that each one of these commands creates a layer within the image. That's where all those steps come from. If you ever notice when you're doing a remove on the image, you'll see all these SHA things that are being removed, and those are the layers that were created by the Docker build. So if you ever wonder what that is, that's what's going on. This is the Docker file we'll be using. Again, this is almost exactly the same as the docs.docker.com file, except for I'm using 3.5 for Python instead of 2.7. I did not have to modify the app. It still works under 3.5 without change. And also the dependencies still work as well, the imports for Flask and Redis. So let's go over to the demo environment. I have a Docker host that's set up, and I have created a build directory already. There's my Docker file, the same as the one I just showed you. And I also will need a couple of other things here. I'll need my Python app. And this is the same application that's in docs.docker.com. So if you want to pull from there, you can. This will work just fine. Now, one thing to remember here is that we're only deploying Python. And you'll notice that there are calls to Redis. The pip command only installed the module for Redis. It did not actually install Redis. And so anytime we're referring to Redis down here, those commands will fail. We're going to, like I said, we'll cover that under Docker Compose. And then finally, I need my requirements.txt, and I have Flask and Redis that I'm pulling into pip to do that. So at this point, I'm ready to do a Docker build. And there's it's basically I'm adding a tag. I'm going to call this friendly hello. Now here I could put in my full path if I wanted to, but I'm lazy. I'm already in the directory, and so I'll use a dot in order to tell the Docker engine to locate the Docker file in my current working directory. So we'll go ahead and do that. It starts to do the pull request, and then it starts to execute my steps. Now, you should get a successfully built at the end here. If you don't, there are some troubleshooting steps that are on the docs.docker conf site, which talk about pip failing because of problems in the DNS configuration. If you're running DNS mask, I will almost guarantee you're going to run into it. DNS mask is, well, it does more harm than good. Let's put it that way. When it comes to using when it comes to using standard applications that are looking for DNS standard DNS calls. So there's a modification you can do to the daemon.json file to get around the issue, and they describe that. So at this point, I should be able to do a Docker image ls. And I'll see two things that are built here. And you're probably wondering why. Why did it do that? Well, the first is my image, is the friendly hello. That's the image that I just created in my build. And the second is the pull request that we made to get Python. Those are going to install as two different images. And that is just the way it works. If I do a, you'll notice that there hasn't been any containers built yet. So at this point, the only thing we have is the image in our system. So let's go ahead and do a Docker run. I'm going to do a -d, which tells it to detach this from the front end, a standard in and a standard out, and then pushes it into the background. And the other thing we're going to do is we're going to expose port 4000 on the outside to the port 80 that's being exposed on the inside. And that is the name of the actual image I want to run. So if we're all good, we should see a number that comes back, which is a long string that is just telling me that, yeah, I started it up, but is it actually running? Let's take a look. Yes, it is. So at this point, let's go over to a browser here. And I have this up from before, but let's go ahead and refresh the page. And you'll see that my host name did change because we created a new one. But there's my Redis failure because we don't have it. So my application is working. So let's go back here for a minute. And at this point, what I can do is I can do a Docker container stop. And I'll do it. It's Nervous Matsumoto. I'll go ahead and do that. And that should shut down the front end. And it'll take a few minutes to bring it down. A few seconds, actually. Not a few minutes, but a few seconds to bring it down. And that's it. And now we can do a Docker container. And we should have nothing running. And I can do a PS-A, and I can still see it there. It's exited. So I think we're all good there. So let's go back and talk a little bit about some next steps. So I have a few recommendations for you when you're deploying applications on containers in production environments. The first thing you might consider, again, all these are recommendations. I'm not telling you what to do. But these are practices that I follow. And they have worked so far for me. First of all, you want to use something, a host OS that is designed for containers. and that is it only exposes what it needs to expose in order to support running Docker. So I would recommend either using BusyBox or using Alpine Linux. There is a version of Alpine Linux called the Mini Root file system that is specifically designed for virtual machines and containers, and so it provides a very thin footprint. If you want and you're interested, we can do a session on that in the future on how to set that up. The second thing is you might want to do is to classify your images according to, is this something I can expose to the internet? Is this something that contains customer data? Is this something that contains payment information? If you have application, I mean, these are just ideas. I mean, you can come up with your own. But in those instances, you do not want to cross-deploy applications on the same Docker host. You would want to put them on their own hosts and then place them in the appropriate location in your three-tiered architecture, which is the next part of this, which means that I have applications that are exposed to the internet, I have applications that are only inside the DMZ, and I have back-end applications that are on my LAN, and all of these are protected by firewalls. And so that is my recommendation. Is you can go N-way too. I mean, you can go as deep as you want, as many layers as you have. I know that in certain cases of really high security payment transactions, those are batched and sent later across, and the payment server is never really exposed to the internet or to the DMZ for that matter. So those are some ideas that you might want to consider. Also, if you must administer Docker containers through either the CLI or through a GUI, use VPN, use security tokens, use multi-factor authentication, but for God's sake, don't expose those clients directly to the internet unless you'd like to have visitors, because I guarantee you they are looking for those, and they will show up. Don't expose anything that contains sensitive images to the public hub. I mean, that should go without saying, but you'd be surprised how many times it's happened to people where they've accidentally posted private code to the public hub. MFA and SSH security keys between hosts in order for you to do SSHs in. Don't use passwords and don't allow root access to those boxes. These things are all common sense kind of things, and it should go without saying, but we do keep repeating the same mistakes anymore out in our systems, like using the same passwords or not changing the passwords on the admin accounts. We seem to be doing that over and over again. Use vulnerability tools that have been certified to work with Docker and have support for containers. And this is another point. If you're pulling containers, now I'm not saying that that this is a bad practice. I'm just saying be careful of where you're pulling your images from. Make sure that you have tested them in a sandbox first to see whether or not there's any malware that's in it. It could be, innocent. It could be somebody who just didn't realize that there was malware in it. It could be someone that's intentionally placing malware in it. That's always a possibility. Not saying that the repository is something to avoid. Not saying that at all. Just saying use good common sense when you're bringing down stuff from the public. Never run Docker commands as root. Always add those users to the Docker user ID. You don't want to be root anytime on any production environment if you can help it. And if you are, take it offline before you do that. Avoid using Docker volumes with read-write access. In fact, you probably should try to reduce your read-write footprint on all the directories on the host system as much as you possibly can. That just gives you one extra layer of things to not have to worry about. If you can't write to the disk, you can't go in and encrypt the file system, as we have seen here in Texas a few times. So with that, I hope you enjoyed this, and next time we'll talk about stacks a little bit more. I know I did promise you that we'll look at Portainer, and we'll get to that. I just don't want to take up a lot of time with this today. So I wanted to give you the basics on how to build, and I hope you enjoyed this. If you did, please like and subscribe. And as always, hope to see you again real soon. Bye for now.